In this video, we're going to look at right triangles and their characteristics. How do you know everything that I'm going to tell you is correct? Well, trust me, I'm always right. So in this video, we have two big questions that we're going to look at. Number one, what is a right triangle? So what things make up a right triangle? And number two, how does the Pythagorean theorem characterize triangles? In other words, how does it make a right triangle what it is? The first thing we have to understand is, how do we define a right triangle? Well, the word right is right in the word. Okay, I'll stop. It is a triangle with a right angle. If the triangle does not have a right angle, then it is not a right triangle. Fun fact, we know that the sum of the angles in a triangle is 180 degrees. If all right triangles have an angle measure of 90 degrees, what does that say about this angle and this angle's sum? Let me get out my calculator. 180 minus 90 leaves this plus this, adding up to 90 degrees. That means in any right triangle, the two non-right angles will always add up to 90 degrees. Fun fact, just for you. The legs of the triangle are the two sides that make the perpendicular. So here we've got A and B being the legs of the triangle. Perpendicular is just a fancy term for right angle. Any two lines that make a perpendicular form a right angle. So it's the two sides that are not the hypotenuse, as you can see here. The hypotenuse is the side of the triangle that is across from the right angle. These words, legs and hypotenuse, are specific to right triangles. So if a triangle is not a right triangle, it can't have a hypotenuse. If a triangle is not a right triangle, it can't have legs. Legs means specifically that those sides form a right angle. If you have any other triangle than a right triangle, we just call them sides. The Pythagorean theorem. Now, this is what some would call the crown jewel of mathematics. The reason why is because it has been proven so many different ways. It has implications in all branches of mathematics. And it goes a little something like this. If and only if, and that's important, if and only if a triangle is a right triangle, then the sum of the squares of the legs is equal to the square of the hypotenuse. The sum of the squares of the leg is equal to the square of the hypotenuse. Ha ha ha. We have to break this down a little bit. Sum of squares. The sum of the squares of the legs. So the squares of the legs is what we're doing first. So a squared, b squared, we're going to sum those. That means we add them together. A squared plus b squared, and that's equal to the square of the hypotenuse. So a squared plus b squared equals c squared. Oh, that formula. Ha 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 ha. That equation. Ha 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 ha. When most people think of the Pythagorean theorem, they remember a squared plus b squared equals c squared, but it means something more than that. We're talking specifically about these two legs. When we square their lengths, add them together, we should get the square of the hypotenuse. There are words and meanings that go along with that equation. If and only if means two things. It goes in one direction. We can say if it's a right triangle, then the side lengths satisfy this equation. And we can say if the side lengths of a triangle satisfy that equation, then it has to be a right triangle. This is called a biconditional statement. It means that logically, if we have something if then, so for example, if P then Q, then we can also say if Q then P is true if it's a biconditional statement. So in this case, if it's a right triangle, then a squared plus b squared equals c squared. So our P would be right triangle, our Q would be the equation. up there, we would say if Q, then P. So our Q, again, is the equation, and the fact that it's a right triangle is the P. So if P then Q, if Q then P, it goes both ways. And there are two of them, biconditional. Bi meaning two. The fun fact that it is a biconditional gives us two kinds of problems that we can get with the Pythagorean theorem. The first one here being the most common, and that is if we know that a triangle is a right triangle, then we can set up this equation here. And that requires us to have two conditions being met. Number one, we have to be given a right triangle. We have to be given that right angle. And then we also have to be given at least two side lengths. And then we can find the missing side length. In this example over here, we're given a right triangle with a leg length of 4 and a leg length of 3. And we can put those two into the equation and solve thusly to get that the hypotenuse is equal to 5. Now this isn't the only kind of type A problem. There are two kinds, either where you have an unknown hypotenuse or you have an unknown leg. So within this one problem type, there are two other different kinds of problems. A practical application of this problem would be, suppose you have a wall and you have a ladder that you want to put up on the wall and it's a certain height. You need to know, will that ladder be able to make it to the top of the wall? That's a pretty classic problem involving this problem type. A type B problem is a little less common. It's basically if a squared plus b squared equals c squared. So if we have a triangle and they meet those conditions, then we can conclude that it's a right triangle. So if we look at our example over here, we've got this thing that seemingly looks like a right triangle. We plug in the values over here. So we assume that these two, 5 and 2, are the legs because they're the shorter ones. We can go ahead and assume that the hypotenuse, if it's a hypotenuse, is going to be the longest leg. So 2 squared plus 5 squared is equal to 4 plus 25, which is 29, but then 7 squared is 49. 29 and 49 are definitely not equal, therefore this thing is not a right triangle. And just because it looks like it, like we said here below, just because it looks like it is a certain measure doesn't mean that it is. It requires proof for us to show that it is a right triangle, which we showed here, it is not. So I lived in a room once where I had to make a studio space and I wanted to put the green screen in a corner, and I had a piece of green cloth that was a certain length, and I had to measure how far on either side to put the thing, and I used something similar to this type B problem to figure out where to place the ends of that screen, or the things to hang that screen up, I mean. So what conclusions can we draw from this? First and foremost, a right triangle is a triangle with a right angle. That is how we define it. Its sides have special names. The two sides that make the right angle are called its legs, and the side across from the right angle is called its hypotenuse. We also know if a triangle is a right triangle, then it satisfies the equation a squared plus b squared equals c squared. And we also know that if it satisfies that equation, if a triangle satisfies that equation, then it has to be a right triangle. And that's because the Pythagorean theorem is a biconditional statement, meaning we can assume if it's a right triangle, then it meets that equation, and then the other way around, if it meets that equation, then it's a right triangle. An example of a statement that's not biconditional would be if it's raining, then it's cloudy. That is true. We need clouds to make rain, precipitation rain. However, it can, in fact, be cloudy without there being rain. So that is not a biconditional statement because it only goes one way. Thanks for watching.